Discrete mathematics is a very important branch of mathematics. Now we start with unit number 2 of discrete mathematics, that is lattices and Boolean algebra. Now the fourth point is Boolean functions. Introduction, Boolean variable, Boolean function of degree n, Boolean identities, definition of Boolean algebra. Let b equal to 0, 1. We define two binary operations, addition denoted by plus called Boolean addition and multiplication denoted by dot called Boolean multiplication on the set B as follows. 1 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 0 is 0. And multiplication as 1 into 1 is 1, 1 into 0 is 0, 0 into 1 0 and 0 into 0 is 0. In the algebra of propositions, 0 belongs to B corresponds to truth value F and 1 belongs to B corresponds to truth value T of the given proposition. The Boolean addition in B corresponds to disjunction, join, and Boolean multiplication in B corresponds to conjunction of two propositions. See what is the meaning of this. We have already seen in logic the table for disjunction and conjunction. So in that table, we take T, T, TF, FT, FF as 4 rows. Now here T is nothing but 1 and F is nothing but 0. So if we replace that table of T and F by 1 and 0, we get the table of addition as table of disjunction and table of multiplication as table of conjunction. Now for x in B, x bar denotes the complement of x and is given by 1 bar equal to 0 and 0 bar equal to 1. Correspondingly, in algebra of propositions, we have negation of t is f and negation of f is t. It means here the complement of x is similar to negation. Now let b equal to 0, 1. Then b2 equal to b cross b is equal to 0, 0, 0, 1, 1, 0 and 1, 1. Similarly, b3 is b cross b cross b, which contains 8 such triplets. In general, Bn is equal to b cross b n times. It contains the n tuple x1, x2, xn where each xi is in B for 1 less than or equal to I less than or equal to n. So it is the set of all n tuples of zeros and ones. Now as B contains two elements, Bn consists of 2 raised to n strings, each of length n. Now what is Boolean variable? The variable x is called a Boolean variable if it assumes values only from B. That is, if its only possible values are 0 and 1. So if the variable takes only two values 0 and 1, then it is called as a Boolean variable. Boolean expression. Any combination of Boolean variables x1, x2, xn and Boolean operation is called Boolean expression and is denoted by e of x1, x2, xn. Now, each Boolean expression represents a Boolean function. Every Boolean function can be represented by a Boolean expression. Now, what is Boolean function of degree n? A function f from Bn to B is called a Boolean function of degree n. It means for every element x1, x2, xn of Bn, f is applied and then that is a unique element of B, which is coming in terms of either 0 or 1. So this is a function of degree n. Now, by preparing a table of values, express the values of the following Boolean functions. F of xyz is x into z bar. Now here there are three variables x, y, z. So function f is defined from B3 to B. Now see how to prepare the table. Now as x, y, z, each variable will take the value 0 or 1. There will be total 8 rows because B3 contains 2 cube, that is 8 elements. So we prepare the column similar to the truth table in logic. Now as function contains x into z bar, we need to prepare columns accordingly. Now for first three columns will be for three variables x, y, z. Now to calculate this part we need z bar and then ultimately x into z bar. So there will be 5 columns and 8 rows. Now how to write the columns of x, y, z. Now first we write 4 rows of x as 1, 1, 1, similar to T, 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 T in the truth table containing 3 variables, and the last 4 rows containing all zeros. Now for y and z, first 4 rows we write as similar to T, 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 F, F, T, F, F as 1, 1, 1, 0, 0, 1, 0, 0, and last 4 rows again same 1, 1, 1, 0, 0, 1, 0, 0. Now considering that addition and multiplication, we write z bar and x into z bar. Now z bar is complement of z. So if z is 1, z bar is 0, and if z is 0, then z bar is 1. So we write the column of z bar. Now x into z bar. Now if x and z bar both are 1, then we get the multiplication 1. Otherwise it is 0. So here x is 1, z bar is 1. So answer x into z bar is 1. Then x1, z bar 1. So answer is 1. And in the remaining cases, either x is 0 or z bar is 0. So the product is 0. So what it represents actually, according to this function f of 1, 1, 1, that answer is 0. F of 1, 1, 0, that answer is 1. So instead of writing in this way everywhere that f of 1, 1, 1, f of 1, 1, 0, it is better to prepare the table. So these are the images under that function we are getting. In the same way, second function is fxyz is x bar into yz plus y bar. Now similar to first example, another function we prepare the table. Now f is defined from B3 to B again. So the table contains 8 rows, and considering the right side of that function, we prepare the columns. Now these are the values finally. Now, Boolean algebra. A lattice is called a Boolean algebra if it is bounded, complemented, and distributed. We denote a Boolean algebra by B bar join mid, where this bar denotes complement. So, a lattice is called as a Boolean algebra if it is bounded, means it has both greatest as well as least element. Complemented means every element has complement, and distributed means both the distributive laws are satisfied. Now atom. Let B bar join mid be a Boolean algebra. A non-zero element A is called an atom if for every x in B, x mid A is A or x mid A is equal to 0. Now what is non-zero element? Non-zero element means it is an element which is different from least element, because least element is denoted by 0. So that element A is called as atom if for every x in B, x mid A is either that element A itself or x mid A is equal to 0. Now consider the set B equal to 0, 1 with the partial order defined by 0 precedes 0, 0 precedes 1, 1 precedes 1. The Hayes diagram for B is given below. So 0 precedes 0, 1 precedes 1 means they are related to themselves, and 0 precedes 1 means at lower level 0 and at upper level 1. The operation tables with respect to operations join and meet are given below. So 0 join 0 is 0, 0 join 1 is 1, 1 join 0 is 1, 1 join 1 is 1. Then 0 meet 0 is 0, 0 meet 1 is 0, 1 meet 0 is 0, and 1 meet 1 is 1. Also 0 bar is 1 and 1 bar is 0, and hence B complement join meet is a Boolean algebra, because 0 is the least element, 1 is the greatest element, means it is a bounded lattice. Every element has complement, means it is a complemented lattice, and at the same time both the distributive laws are also satisfied. So it is a Boolean algebra. If we treat 0 as truth value false and 1 as truth value true, then the operations join and meet can be identified with logical OR and logical AND respectively. The operations join and meet on a Boolean algebra are sometimes denoted by plus and multiplication respectively. Now consider B2 is equal to B cross B, which contains 0, 0, 0, 1, 1, 0, 1, 1. Define the operations as follows. AB join CD is equal to A join C, B join D, and AB meets CD is equal to A meets C, B meet D. The operation tables are as follows. Now here we prepare the table for join and meet separately. Now these are the elements of B2, that is B cross B, written in row as well as in column. Now we apply for each coordinate separately. So for 0, 0, 0 join 0 is 0. So it is 0, comma 0. Same way as 0 join 1 is 1, we are writing 1 here. Then 0, 0 join 1, 0. So 0 join 1 is 1 and 0 join 0 is 0. So it is 1, comma 0. Same way 0, 0 join 1, 1 is coming 1, 1. So in this way, considering the 0 join 1, 1 join 0, 0 join 0 and 1 join 1, we do it for every pair. Same way, this is the table for meet. So here the definition is given. So using these two definitions, we have prepared table for join and meet. Now we find complement of each element in B2. Now this is the hash diagram. This is 0, 0, 1, 0, 0, 1 and 1, 1. So 0, 0 is the least element, 1, 1 is the greatest element. So complement of 0, 0 is 1, 1. Complement of 1, 1 is 0, 0. Now to find the complement of 0, 1, we must find pair AB such that 0, 1 join AB is equal to greatest element 1, 1 and 0, 1 meet AB is least element 0, 0. So we find complement of 0, 1 using tables of join and meet. Now in the table of join, 0, 1 join that pair AB, that must be greatest element 1, 1. So in the row of 0, 1 we are getting 1, 1 for 1, 0 and 1, 1. But for the same pair meet must be 0, 0. So observe the table of meet. In the row of 0, 1, 0, 1 meet 1, 0 is 0, 0. But 0, 1 meet 1, 1 is not 0, 0. So 0, 1 join 1, 0 is 1, 1 and 0, 1 meet 1, 0 is 0, 0. So complement of 0, 1 is 1, 0. Similar way, complement of 1, 0 is 0, 1. So every element has complement and hence B2 is a Boolean algebra. Now the next part is finding the atom. Now by definition, atom is a non-zero element. So it must be either 0, 1 or 1, 0. Now for that, observe the table of meet. So 0, 1 meet 0, 0 is 0, 0. Then 0, 1 meet 0, 1 is element itself. 0, 1 meet 1, 0 is 0, 0, which is again 0 element. And 0, 1 meet 1, 1 is again 0, 1. So if we consider 0, 1 meet every element, we are getting either 0 element or 0, 1 itself. And so 0, 1 is an atom. Same way in the table of meet, 1, 0 meet 0, 0 is 0, 0. Here also 0, 0, here also 1, 0 and 1, 0. So 1, 0 meet AB is 0, 0 or 1, 0 itself. So another atom is 1, 0. Now for 1, 1, 1, 1 meet 0, 1 is not 1, 1 or 0, 0. So 1, 1 is not an atom. Remark. We can extend a partial order relation defined on B2 and B3 to Bn, where Bn is B cross B cross B n times, which contains n tuples x1, x2, xn, xi in B for I1 to n. That is the set of all n tuples of zeros and ones. On Bn, we define a relation as follows. For x is equal to x1, x2, xn and y is equal to y1, y2, yn. X precedes Y if and only if Xi precedes Yi for all I. With this partial order relation, we have the following. X meet Y C1, C2, Cn where Ci is minimum of Xi, Yi. And X join Y is D1, D2, Dn where Di is maximum of Xi, Yi. And then Bn is a Boolean algebra. Now, next example, let A is AB, show that P of A is a Boolean algebra. Also find atoms in P of A. Now as A is AB, P of A contains phi singleton A, singleton B and AB. Now for xy in P of A, x join y is their union and x meet y is their intersection. So we prepare the table of join and meet considering their union and intersection. So this is the table of join which is obtained by taking union of that particular elements, and this is by taking intersection. Now, as already we have seen that phi is the least element and AB is the greatest element, it is a bounded lattice. Complement of phi is AB and complement of AB is phi. Now, by observing these tables of join and meet, complement of A is B and complement of singleton B is singleton A. Thus, complement exists for every element, means it is a complemented lattice. Also, both the distributive laws hold, and hence P of A is a bounded complemented distributive lattice. It means it is a Boolean algebra. Again, to find the atoms in P of A, consider the table of meet. Now for singleton A, in the row of singleton A in a table of meet, we are getting all elements as phi or singleton A only, means either 0 element or the element singleton A itself. So singleton A is an atom. In the same way, in the table of meet, in the row of singleton B, we are getting all elements as phi or singleton B. So singleton B is also a atom. Now, AB is not an atom because AB meet A is A, which is neither phi nor AB itself. So the atoms in P of A are singleton A and singleton B. Now, next example, determine if the coset D48 is a Boolean algebra. Now, D48, set of all positive divisors of 48. Now here, number of elements in D8 is equal to 10, which is not in powers of 2. So according to fourth remark that every finite Boolean algebra contains 2 raised to n elements, we can say that D48 is not a Boolean algebra as number of elements in D48 is not in the form 2 to the power n. Or you can use here third remark also because it is in the form of Dn. Now these are some identities in a Boolean algebra. Let B be a Boolean algebra, then for xyz belonging to B, following identities hold.